Swanand sir.
Hello, sir.
Sir, we will start exactly at 10:30.
No problem, no problem. आता आले जजमेंट त्यामुळे नसलं चालू असलं तरी कळतं एवढं करावं लागेल.
Good morning, all. So we are going to start our second day of FDP on essential mathematics for engineers and researchers. For today's first session, our speaker, I will introduce him briefly, Dr. Swanand Gajanan Kulkarni. Currently, he is working as an associate professor in Department of Mechanical Engineering at SKN Sinhagad College of Engineering, Pandharpur. He has completed his PhD from Sardar Vallabhbhai National Institute of Technology, Surat in 2017. He is having total 17 years of experience. Out of that, 4 years is from industry and 13 years is from academics. He is a member of Indian Society for Technical Education. Also, he is a member of Institute of Engineers, India, Kolkata. Also, Indian Association for Computational Mechanics. He has presented 14 papers in international conferences. He has published 24 papers in international journals. He has filed one patent on portable lead-based integrated assembly to examine microstructure of opaque objects using ball lens. He has worked as a remote center coordinator of IIT Bombay and IIT Kharagpur. He has worked as a coordinator for university level research project exhibition Avishkar 2017. He is working as an institute member co-curricular for Unnat Bharat Abhiyan. He has worked as co-convener for international conference ICSI-CM 2020. He has worked as co-editor for an issue of journal Material Science and Engineering, IOP publisher. He has received some funds he has worked as a principal investigator for seed money research project of Solapur University, Solapur, on utilization of sugar factory industry waste in enhancing wear resistance material properties for automotive application. He has worked as principal investigator for funded research project of Department of Biotechnology on use of flood scope for taking microscopic image of composite material to identify microstructural details like matrix and reinforcement phases, porosity, cluster formations, grain formations, etc. Also, he has worked as a principal investigator for funded research project of Unnat Bharat Abhiyan on utility-based biogas plant running on solid waste for use of renewable energy. So this is what the brief introduction of our today's resource person, Dr. Sonan Kulkarni. Now, I request Dr. Sonan to start his session. Thank you.
So thank you very much, Yasvi Pawar sir. I'm grateful to General Science and Engineering Department, in SKN Sinhagad College of Engineering, Mr. A.I. Nikam, Dr. H.G. Deshmukh, Yasvi Pawar, and all the team members from General Science and Department organized nicely this particular session on mathematics, because without mathematics and softwares, it is not possible to carry any kind of research. Maybe it is PhD work, or maybe it is any kind of research work, which is not possible without the support of mathematics as a part of science, engineering, and nowadays for other disciplines also, mathematics is very essential part. And that's why, with keeping that things in mind, this nicely organized this particular workshop for all the audiences present here. So good morning to all of you. Basically, whenever we carry out any kind of work, maybe it is based on the science or engineering, we need to take the supports of various mathematical models. And that particular mathematical models are required because whatever the things we have got from our experimentation, so in order to make them proper documentation of all of this, and at the same time, in order to prove our hypothesis, our results, required some theoretical support, and with that way we are always looking for a best mathematical model which will be useful for us, so that more experimentation we can save, at the same time we can predict some of the experimentation if number of parameters are known to us. So mathematical models are usually composed of relationships and variables. So maybe there are various types of models. I will take some brief review. So relationships can be described by operators such as algebraic operators, functions, differential operators, etc. Variables are abstractions of the system, parameters of interest that can be quantified. So several classification criteria can be used for this mathematical model. So in general, if we talk about the mathematical models, there are the requirement of different models, and each and every kind of mathematical model will be useful in different kind of situations. And based on the strong points of our experimentation and our work, and based on the relevance of that particular model, we are choosing one of the model which is best suitable for all of us. In general, whenever the data is deterministic and linear type of models are there. If it is not linear type of in nature, there are non-linear type of models are there. If the systems are stable and steady, we are taking the support of static type of models, and if that are in the motion, dependent of models, basically explicit and implicit. So that is also one kind of type of models, mathematical models. Whenever we know the output and only we have to change the input, then explicit type of models are used. But if output is known and with reference to our computational techniques, if we are interested to find the input, then we will have to go for the implicit type of models. Maybe if all the things are in situations and in your hand and it is in control things, then if parameters are in control of positions, then deterministic type of models we can use. And if suppose the kind of situation is not in our hand, the number of parameters which are not in our hand, then probabilistic type of models we will have to prefer. At the same time, if a particular point, if suppose we take the example of molecular dynamics and one of the point is present, one of the particle in this molecular is moving, then that kind of behavior of that particle will be discrete type. And if it is not particular one point related, if suppose it is the case of stress, it is the case of force, it is the case of thermodynamics, it is the case of heat, etc. Then in that case, this can be considered to be as a continuous type of model. Is it okay? In case whenever the models are with reference to one point discrete, and if it is with reference to continuing process, then continuous type of models. So likewise, there are many examples like deductive, inductive, floating type of models. If there is any decision we have to take, based on that decisions, then strategic type and non-strategic type of models are also there. Coming to this regression analysis, this is a very simple tool. Basically, many number of models though are available. This is regression is a statistical modeling, and this regression analysis is a set of statistical processes for estimating the relationship between dependent variable and one or more independent variables. So what is that dependent and independent variables? That part we are going to study thoroughly. The earliest form of regression is in the form of method of least square. So method of least square approximation is one of the successful mathematical tool which is used for the regression analysis. And if we go for a small history of this regression analysis, then we will come to know that in 1950 to 1960s, economists used electromechanical desk calculators to calculate these regressions. So in 1970 or before that region, it sometimes took near about 24 hours to receive the results from the regression. So regression methods continues an area of active research. So in 2020 also many good articles, research journals that are coming by taking the support of regression analysis. Basically this regression analysis is very vast. Maybe it is a simple type of regression analysis, multiple type of regression analysis, polynomial type of regression analysis, then linear type of regression analysis, non-linear type of regression analysis, multi-collinearity is the type of relations, then various tests factors are there. Whatever the mathematical model has been developed, this model is always tested, so various tests are present. So that is very vast area. So regression analysis is not the domain where one can explain this particular tool in 1 and 2 hours, but it is very vast type of tool, regression analysis. So starting from simple linear regression to multi and as well as polynomials, then linear, non-linear, and all these things that are present. And that's why it is difficult to complete in 1 to 2 hours. But a small review we will try to take on this regression analysis in simple linear regression, regression types of regression models, scatter plot, the basic assumptions, then standard deviation, R value, NO, and some of the examples we will try to take with this regression analysis. So though word is simple linear regression analysis, so simple for the research, simple has very important in case of research, because life is not complex, it is simple. We become it as a complex because life is simple and the simple things is the right things. So nature is pleased with simplicity, as per the Isaac Newton. Don't make the process harder than it is. If it is simple thing, then it is. Don't make it as harder. So with this, we'll come to this simple linear regression model. So regression analysis is a statistical tool for investigating the relationship between a dependent variable and one of the more independent variable. Regression analysis is used for prediction as well as forecasting. So many more areas are there. If we take example of economics, if we take example of management, if we take example of life and biological science, if we take example of physical and chemical science, in engineering as well as in social science. So if we look towards the application area of regression tool, then we'll come to know that for many more areas and many more fields, this particular type of mathematical model is applicable. Without economics, without management, without life and biological science, physical and chemical science, engineering and social science, nothing is possible. And for these all areas, the regression analysis tool is useful. So as far as concerned with this simple linear regression model, suppose we take example of y is equal to beta 0 plus beta 1 x plus epsilon, then the terms which are associated with this simple model, inside which this x will be the parameter which will not dependent on anything, but this particular will decide the value of y. So y is equal to beta 0 plus beta 1 x plus epsilon, inside which this x will be considered as a regressor variable, or we may consider it as an independent variable. X is independent or regressor variable, and this particular y, the value of y will be calculated based on the value of x. So that's why this y is considered to be dependent variable. The y is also known as a response variable. So x is regressor variable, y is response variable, or x is independent variable and y is dependent variable. So remaining terms which are associated with this, that is beta 0, beta 1 and epsilon. So inside which this beta 0 will consider as one kind of intercept. So we are taking one example, and how to find that intercept that we are looking further. Beta 1 is considered to be slope, beta 0 is intercept, beta 1 is slope, and epsilon is considered to be a random error of computation. Means maybe sometimes whatever the values calculated based on this model and actual values, maybe there are certain differences. So error, so random error, that is also considered, and that random error is added, so that this total model will have good confidence level. So y is a random variable, x is not a random variable. Here important term is y is considered as a random variable and x is not random variable, it is controlled variable. So x is specific, that is known to us. It is the study, so regression analysis is the study of a relationship between variables. It is one of the most common tool used for business analysis. It is easy to use and applies to many situations. So simple regression, a single explanatory variable in the regression types. So regression analysis is carried with this way, but regression types are basically, it is broadly classified as simple regression, multiple regression. So for simple regression, single explanatory variable, and in multiple regression, it includes any number of explanatory variables. Suppose one parameter is there, which is y and x, both are there, x is 1 and y is calculated based on only one x, then that will be simple regression. But if parameters are more than one, then in that case, that will be the multiple regression. So that includes any number of explanatory variables. So there is no any control on that variables. For example, here if we see y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus up to n numbers beta n xn plus random error epsilon. So here, if we give the names to these particular parameters present in these equations, then as already said that y is dependent variable. Then beta 0, beta 1, beta 2 up to beta n, all these betas, these are the coefficients. Then x1, x2, x3, x4 like this. So these are explanatory variables. And epsilon in this case is considered to be a random error term. Is it okay? So in brief, this regression model, so for that again the dependent variable, the single variable being explained, predicted by the regression model. So already we have seen that y is considered to be dependent variable and x is considered to be independent variable. So dependent variable is the single variable being explained or predicted by the regression model, and independent variable is the explanatory variables used to predict the dependent variables. So all the coefficients, so that coefficient values are computed by regression tool reflecting explanatory to dependent variable relationships. So maybe it is beta 0, beta 1, beta 2, etc. up to the beta n. And epsilon or random error, it is also considered to be residual. So residual, the portion of dependent variable that is not explained by the model. So this is not in the hand, or it is not in the control of that model. So that terms will be considered to be residuals. So the model under and over predictions. So that is the residual part. The simple regression line provides the estimate of population regression line. So here one of the model example is shown here, that yi hat, to this particular symbol yi hat, that is estimated or predicted y value. Then beta 0 or b0, here it is considered to be intercept, and b1 is considered to be estimated or regression slope, and x is independent variable. So with that types of regression model, so in that types of regression model we can see here that the first example where positive x-axis and positive y-axis, so this relationship of x and y, that is moving linearly with positive x-axis and positive y-axis. So that is strong positive relationship, so inside which the slope is also positive. In second case, in second example, if we see the strong negative relationship, in that strong negative relationship, here we can see that this positive x-axis, the variables are moving toward positive x-axis and positive y-axis, but this particular slope. So this line, if we understand the behavior of this particular model or behavior of this dependency in between y and x, if we will try to identify, then as here values of x are increasing, the values of y decreases. Initially, the value of x is less, then y is large. Later on, x value starts to increase and y value starts to decrease. And this particular relationship between these two is considered to be strong negative relationship between y and x. Further, if we consider the third case, then in this third case, if X and Y. So these particular points are plotted. Maybe first two last points, whatever the possible experimental points, evidences, or whatever the data available, if in which we have to identify the relationship. And if these are coming in scattered manner, which is shown in this figure third, then there cannot be established the relationship between them. So in that case, there is no relationship in between all of this. Okay. So further now we are going to this scatter plot. So before going to scatter plot, the scatter plots are used to investigate the possible relationship between two variables. Maybe it is a regressor and response variable. So scatter plots are used to investigate the possible relationship between them. If the scatter plot indicates sort of linear relationship between the variables, then we need to go for linear model. See, so whether the model is model we want to construct, whether that is linear model or that is a non-linear model. In case of non-linear model, there may be cubical type of model, or there are many other types are also present. So which kind of model we are going to construct? So that will be decided based on the scatter plot. So scatter plot will indicate the sort of linear relationship between the variables. Then we need to go for the linear model. If we found that there is no linear relation between X and Y, in that case, we can take the support of non-linearity. Is it okay? So, but if the scatter plot indicates the sort of non-linear relationship between X and Y, then we'll go for the quadratic fit or cubic fit or higher loaded polynomial fit. So any type of this particular fit we can go for. Maybe it is quadratic type or cubic type or higher loaded polynomial fit. But we should know initially the scatter plot of Y and X. So looking at this scatter plot, now we will plot one of these scatter plot and we'll try to identify the relationship between them. So here this one scatter plot is shown here. X, we can see here that X is present from 0 to 5 and Y is moving from 0 to 5 here. One example we will consider here, that suppose Xi, which we are considering as independent variable, and Yi we are considering to be dependent variable, or Xi regressor variable, Yi as response variable, then value of Xi, that is 1, 2, 3, 4, 5, that is 5 readings we are going to take for this Xi, then corresponding value of Y. This is particular example which we are going to use for this throughout case study. Maybe this particular example is cast with reference to the cost of the advertise and whatever the profit getting. So if $1 is the cost of advertising, and if anybody is getting the profit of $1, $1. So if 2 is the cost of advertising and 1 is the, maybe in any unit, there is no any kind of particular rupees or dollar, it may be in any unit. If 1 is the unit of cost of advertising and if 1 is the this particular profit this firm is achieving, if 2 is the advertising cost and again 1 is the profit they are achieving. If advertising cost increased to 3 and now this is going to the profit is increased to 2 times. If advertising cost is again still, and if it is increased to 4 and we are getting that profit as 2. Similarly, if suppose advertising cost is increased to 5 times and then profit is increased by 4 times. So likewise, these two variables inside which regressor and response variables inside which relationship we have to establish. Then scatter plot is mathematical diagram to display value of two variables. So here X is the variable which is shown here from 1 to 5, and at the same time Y is the another variable which is plotted on the vertical Y axis. So scatter plots are used to investigate the possible relationship between these two variables, maybe y and x. So inside that, if take one first point of first case we are taking, so xi is 1 and yi is also 1. Then xi and yi that is plotted, here we got 1 point. Then second case, xi is 2 but yi is still 1. So second point is plotted here. So 2 and 1, this point is also plotted here. The third case that xi is 3 and yi is 2, this third case is plotted here. Similarly, fourth case, 4 and 2. So x is 4, y is 2, that case is plotted here. And likewise, 5 and 4. So x is 5 and y is 4. So this last point is also plotted here. Then that scatter plot that is observed here. So looking at this scatter plot, it is observed that this scatter plot indicates sort of linear relationship between response variable and regression variable. So to fit a linear relationship, more specifically simple linear regression for given response variable and one regression variable is required. So here if we now go further for this kind of relationship, then we will come to know that how these particular plots are plotted. Now coming to the structure of regression, so once again this particular part already we have discussed, that is y is here response variable, so x is regression variable, beta 0 is intercept, beta 1 is the slope, and e is epsilon is random error. So before going further, this whatever the example we have taken, and we have to fit this particular example, or we have to go for the making the regression analysis equation for this. So before that, for any mathematical model, because that particular model is stable with particular assumptions, so for any mathematical model there are certain assumptions. Without any assumptions, no any model is valid, or that particular model is valid with that assumptions only. So number of times it happens that this mathematical model is not working because whatever the assumed data for that mathematical model is not particular, or these particular tests are carried beyond the assumption of that mathematical model, and then this mathematical model doesn't works. So which is true for this regression analysis also. So there are certain assumptions for this mathematical model. The first assumption is that epsilon, so epsilon is the random error. We have seen this particular equation inside this y. So the response variable y, and this x is the independent variable or regressor variable. So y is given as beta 0 plus beta 1 x plus epsilon, where the first assumption is that epsilon I is a random variable with 0 mean and variance sigma square, which is unknown. So let us take brief review on the term what is meant by variance, what is expectation. So expectation describes the average value. Always expectation is mean, or it describes the average value, and the variance describes the spread, so amount of variability around the expectations. So these terms are important here because that terms we are going to use for this mathematical model. So for this, expectation describes the average value, and the variance describes the spread or amount of variability around the expectation, so amount the mean value, so particular mean value, and around this mean value, how this spread is there, or how this variability is there, so that will be described with variance. The expected value is measure of location of central tendency. So the expected value is measure of location of central tendency, and the standard deviation is measure of spread of scale. Okay. So we should understand this thing, that expected value is measure of location, for which particular location this value is present, or central tendency, where this particular value is coming as a central value. This is expected value, and standard deviation is measure of spread. So how much these particular values are spread, maybe above or below of that central value. So that is described with the help of standard deviation. And particularly the variance is the square of standard deviation. So expected value, standard deviation, and variance, these three things which are coming from statistics, so that is needed here. So expected value, standard deviation, and variance with its usual notations that we are going to use here. So the first assumption, once again, the epsilon. So epsilon is the random error. So for this particular case, epsilon is shown with this model, and this random variable with zero mean. So it is assumed that random variable has mean value as 0, or its expectation is 0. That means the random variable, it is random, it will move toward the positive side also, it will move toward the negative side also. But overall, if you take the expectation or mean of that particular variable, then it comes equal to 0. And if we try to take the variance, then it is unknown. That is the, so epsilon I, this particular I term is used because any reading that represents the I. So from 1 to n, any place, this is I. Suppose n number of variables are there and I is intermediate of them, then any value of this is considered to be I. So epsilon I, the error term is the random variable with 0 mean and variable sigma square, which is unknown. So that means expectation of epsilon is equal to 0 and various epsilon equal to sigma square. So this is the first assumption for this regression equation. The second assumption is that epsilon I and epsilon j are uncorrelated with each other. So say from 1 to n, in between that, if suppose I have taken error for second reading, and if I taken a reading for fifth reading, then epsilon I will be the ith value, and epsilon j will be the jth value for second and fifth. If we consider, if we try to find error, identify error, then there cannot be any kind of relationship between them. That is uncorrelated. So we cannot find any kind of relationship between the random error and these are uncorrelated. So I not equal to j, that is the required condition here. So the covariance between epsilon I and epsilon j is equal to 0. There is no any kind of the relationship between the random error at I value and random error at j value. Is it okay? So the covariance between epsilon I and epsilon j is equal to 0. Epsilon I is normally distributed random variable with mean 0 and variance sigma square. The mean, we are assuming that epsilon I follows normal distribution with mean 0 and variance sigma square. Is it okay? So y is a random variable, x is controlled variable, and it is deterministic variable. It is not random variable. Okay. So with this, once again, this particular assumptions which we have studied now. So if yi, in terms of this equation we will study, so yi is the any ith value. So if only y we are using, this is generalized form. If I suffix we are giving, then any I value which is intermediate from 1 to n. So if beta 0 plus beta 1 xi plus epsilon I, that indicates that beta 0 with usual notations, we have seen that beta 0 and beta 1, that is maybe intercept slopes, that we have seen. Xi is the ith value of the x. So ith value of x is known, and based on that we are calculating this yth value. So epsilon I is the random variable with 0 mean, and variance sigma square is unknown. So that is expectation of random error at ith value is 0, and variance of random error at ith value is sigma square. The second one is that random variable at ith value and random variable at jth value are uncorrelated, so there is no any relationship where I is not equal to j. So covariance of epsilon I and epsilon j is equal to 0. So that is the second assumption. And epsilon I, that is random error at ith value, is normally distributed random variable with mean 0 and variance sigma square. So it is the normal distribution. So here we can say that the epsilon I, so it is independent. I and D represents the independent. So epsilon I is independent on the normal distribution of 0 and sigma square. Okay, so that is the basic assumptions of the model. So simple linear regression model with this particular usual notations which we are using here. So with that, epsilon I is random variable with 0 mean and variance sigma square. So expectation of random error I is 0 and variance of epsilon I is sigma square. EI and EJ are uncorrelated. I is not equal to J. That is covariance of epsilon I and epsilon J is 0. And epsilon I is normally distributed random variable with mean 0 and variance sigma square. So here it is independent on this normal distribution. So EI is given here. Now here with this particular ith value of yi, the straightforward equation yi is equal to beta 0 plus beta 1 xi plus epsilon I. If we try to take the expectation on both sides, so we have taken the expectation for this particular equation. So all of you know that this is the mean value. Expectation means from both sides it is taken. So expectation of beta 0 as it is a constant value will be beta 0 as it is. So beta 1 is also one single value, that is beta 1 as it is, and xi is the particular value. For that value we are going to identify the yi. So there is no certain change, there will be no any change in that. So that's why the expectation of yi on both sides if we are taking will get the expectation of beta 0 plus beta 1 xi plus epsilon I, because expectation of random error we have considered equal to 0. So this term will not present here. So expectation will be beta 0 plus beta 1 xi. Similarly, if we try to identify now with the based on these assumptions, now if we are taking the variance, then variance of this yi will be equal to variance of this particular beta 0 plus beta 1 xi plus random error epsilon I. Then that becomes the variance, because variance is the spread value. So that is the spread. So sigma square. So this variance of this random error will be shown with the sigma square. So epsilon I is not dependent on the normal distribution of 0 and sigma square. So here we may consider that yi, so ith value of y, so independent of normal distribution of beta 0 plus beta 1 xi and sigma square. Is it okay? So same terms that we have with reference to the assumptions which we have made. With reference to that assumptions, expectation of yi and variance of yi that we have calculated, that we have identified for the ith value of the y, and with that we'll come to know that this particular expectations and the variance of random error and a yi term that we have calculated here. Is it okay? So this is the normal distribution. So here we can say that suppose this particular model y is equal to beta 0 plus beta 1 x. This line represents the relationship between y and x term. Suppose the first term is x1. So for that x1 corresponding value of y1 is given here in bracketed quantity x1 y1. Then maybe here another single point which is shown here, it is x2 y2, and third point is x3 y3. So this is least square approximation technique which works on the approximation of the square terms or the least value of the square term. So if we try to plot one line which will represent all these variables and these x and y values, then for each value there is certain normal distribution, and that normal distribution of x1 y1 is shown here, x2 y2 normal distribution is shown here, and normal distribution of x3 y3 that is also shown here. So this random error that is independent of normal distribution of this 0 and sigma square. So this particular term which can be seen with this particular graph, is it okay? So yi is also independent of normal distribution of this. So this can be observed with this particular case. So sum of squares of all vertical discrepancies as small as possible. So least square estimation of the parameter. So this is very important part because the regression model is related to the mathematical terms here, and for that purpose least square estimation, this concept is very, very useful. The parameters beta 0 and beta 1 are unknown and that are estimated using the sample data, that is the x1, x2, x3 up to the xn, and y1, y2, y3, yn. So that values are initially known to us. Maybe any experimentation is carried, and with that experimentation, suppose we have given the input values as x1, x2, x3, x4, and we are getting the outcome variables as y1, y2, y3, y4. Then, in order to establish the relationship between that x and y, here we have the set of that experimentations. In first set we got the x1, y1, then in second set we got the x2, y2. Likewise, the number of experimentations are carried. We'll take once again same example here. Suppose the advertising cost is $1, $2, $3, $4, and $5, and sale that due to this advertising cost as an input, whatever the sale that is increased, that sale is 1, 1, 2, 2, 4, like this. So if we try to plot them, suppose the first plot is shown here. In that first plot, x is changing from 1 to 5, y is changing from 1 to 5. These all the points are plotted here in both the graphs. We can see here that x1, y1, x2, y2, x3, y3, x4, y4, x5, y5 that are plotted. But here there may be the question that whether this particular line which is shown in first graph is possible or the line which is shown in second graph is possible. Then possibility of the line. Because this particular line will give the intercept also, and that will decide the slope. The slope of that line as well as the intercept of that line, so that is going to decide the value of beta 0 and beta 1. Is it okay? So here the combination of this beta 0 and beta 1 will change with first graph and second graph. Which one will be used? Which line should be preferred? So for that purpose, we will have to take the support of least square estimation. Is it okay? So what is that least square estimation? So with this particular slide, we can understand this particular least square estimation of the parameters. So here, if we take the example of this particular point, suppose y hat is shown here. So y hat is equal to beta 0 hat plus beta 2 hat x. So here you can say, so for this particular case, suppose fourth value we are plotting here, and for fourth value we are getting x4 as well as y4 values. Then here you can see that for x4 y4 combination, the particular x4 is constant because x4 is the input. The value of y4 will be decided. So particular case of y4 will be considered as y4 hat, and this x4 y4 values that will be considered here. Now exact value, actually exact answer or actual value means whatever the results in at actual we have got, so that particular are considered to be y4, but y4 hat is the calculated value, means in actual existence value is y4, but after calculation of the model, after making the fit of this model, we are getting that value as y4 hat. Y4, the difference between y4 hat and y4, we should understand here. What is meant by y4? Y4 is an actual value. After experimentation, whatever the value we are getting, that is exactly y4. And after this particular fit of this model, value of y4 which we got, that is the y4 hat. then the difference between these two will be considered to be random error. So here y4 minus y4 hat, this will be considered to be random error. So this sum of square of such a residuals means this will be considered to be one kind of residual for fourth observation. For each and every observation we can observe. For each and every observation we are getting certain error. So in some cases that error may be zero, but other cases that is not the case. In some cases that will be on positive side, in some cases that will be on a negative side, in some cases that may be zero, but error is the difference between actual y value and calculated or the values coming from the regression model. Is it okay? So here y hat is equal to beta 0 hat plus beta 2 hat x, and if such all errors which are the coming due to the difference between this actual value and modeled value or fitted value, if we try to identify the square of sum of square of such all errors, then that is sum of residual. We can say it as sum of square of residual. So square sum residual. Yes, residual. This term is shown here. So yes, residual is the summation of I is equal to 1 to n ei square. Inside this ei is random error for each and every observation. Maybe it is for observation 1, 2, 3, 4 or 5. For each case, this error is considered to be y4 minus yi minus yi hat, because each and every case and summation of that is taken. Wherever that summation is minimum, that plot is considered to be, if we consider this particular, then wherever we are getting this as minimum, that particular plot is selected. Suppose this particular first case we are observing here. In that first case, the line plot is shown. In second case also that line plot is shown. But which line plot will be selected? The line plot which has yes residual is equal to summation from I to n, ei square is minimum, that particular plot will be accepted here. So that is the least square estimation of parameter. So that is very important task which is present here. So with the help of this only, the basics of regression we can understand, and based on that this particular model is selected. Is it okay? So here we can see that yes is equal to yes residual, which is summation from I to n ei square. So ei is the random error, it's a square, so it must be minimum. So summation of I is equal to 1 to n ei square, that must be minimum. So that is the base by which least square approximation is plotted, and whatever the model fitted, the value or line fitted, that is accepted here. So here we can have this ei is nothing but yi minus yi hat, it's a square. So summation of yi minus yi hat, it's a square, inside which if we particularly put the values of yi hat, yi is any actual result after experimentation we are getting, but yi hat is the model result, and that is replaced by beta 0, means with our model value beta 0 hat minus beta 1 hat xi. So this is replaced by this yi hat. Is it okay? As this particular summation of random error, that is we may consider that as a mean of that, expectation of that random error is considered to be 0. So that is not considered, but this summation of yi minus beta 0 hat minus beta 1 hat xi and square term of that, if we take summation, that must be minimum. With this base, this particular model works. Is it okay? Now here, so this minimization function, so with this yes value, now with reference to this yes value, if we are referring this yes, then definitely that yes is summation from I to n. Wherever summation term is here, that summation means summation is from I to n. So summation from I is equal to 1 to n yi minus beta 0 hat minus beta 1 hat xi, its square. Now if suppose we are taking minimizing this function in order to first order condition with respect to alpha and beta. So we are taking the differentiation of this with reference to beta 0 and beta 1. If we take this differentiation with respect to beta 0 and beta 1, then that must be 0, because we want this as minimum value. So minimization, this problem is solved for minimization, and for that minimization here differentiation is taken for this s value. This is sum of square to s value, and after taking this differentiation, this we are getting the terms which are associated minus 2 epsilon I is equal to 1 to n yi minus beta 0 minus beta 1 hat x1 is equal to 0. And second case, the differentiation of this s is taken with reference to beta 1. So dou s by dou beta 1 is equal to minus 2 summation I is equal to 1 to n yi minus beta 0 hat minus beta 1 hat xi. So this particular differentiation is coming like this. So this is equated to be equal to 0, and these are mathematically solved for beta 0 hat and beta 1 hat. So these are mathematically solved. So with this we are getting that beta 0 is equal to the value of beta 0 and beta 1 that are calculated here. So with this we will consider this beta value of beta 1, how to calculate the beta 0 and how to calculate beta 1. So the base of that we can understand here. So with this least square approximation, this sum of residual square sum of residuals, that is minimized, and based on that the values of this beta 0 as well as beta 1s are calculated. Is it okay? So beta 1 hat, beta 0 hat is equal to y bar minus beta 1 hat x bar, where after solving this particular two equations for beta 0 and beta 1, here we consider that beta 0 hat is equal to y bar minus beta 1 hat x bar, where x bar is summation of xi upon n and y bar is summation of yi upon n. Is it okay? So here in short these particular values are identified. So dou s by dou b1 which is shown here, that after taking this differentiation and these values, compiling this, we are getting beta 1 as equal to summation from I to n yi minus y bar xi summation I is equal to 1 to n xi minus x bar, that is xi. So this again converted into the form that summation I is equal to 1 to n yi minus y bar xi minus x bar, and summation I is equal to 1 to n xi minus x bar. So this beta 1 is considered to be here. So with this we may consider that this particular part of beta 1 and beta 0 calculation, so that is shown here. So in simple manner we can see beta 0 is equal to y bar minus beta 1 x bar, and beta 1 is equal to summation I to n yi minus y bar x1 minus x bar, and here summation I is equal to 1 to n xi minus x bar its square. Is it okay? So these two values which are calculated here. Is it okay? So beta 1 hat, it is we may consider as a ratio of sxy upon sxx, or summation of yi minus y bar xi minus x bar divided by summation of xi minus x bar its square. Is it okay? So what is x bar and what is y bar? That is already given here. So x bar is summation of xi upon n and y bar is summation of yi upon n. Is it okay? So let us come to the basic example so that we can identify the value of beta 1 and beta 0. So this is one example which is shown here. the same example we are continuing with. So the example we have taken for the advertising cost and whatever the sale. Suppose X is considered to be advertising cost. So advertising cost is rupees 1, rupees 2, rupees 3, rupees 4, rupees 5. And with reference to this advertising cost, whatever sale has been observed, that sale is rupees 2, rupees 4, rupees 5, rupees 4, rupees 5. Maybe it is in rupees or in dollar. Unit is not important. The relationship between that is important here. So if X is given with this variables, so X is the actually exactly expenses made against the advertising, and Y is the outcome coming due to this expenses made. So here summation of this we are now going to take. So here if we take X minus X bar, is it okay? So X bar, that means summation is identified with this. X bar is the sum of them. Mean is calculated. So here if we take the mean of that, expectation of that is calculated. So 2 plus 3, 3, 6 plus 4 plus 5, like this. So here we take the X minus X bar, then this row is coming, then Y minus Y bar. This is the again this X bar is considered to be equal to 3 here, is calculated equal to 3 here. So X minus X bar, minus 2, minus 1, 0, 1, 2. Likewise, Y minus Y bar is considered to be 4 here. So 2 minus 4, 4 minus 4, 5 minus 4, 4 minus 4, and again 5 minus 4. So X minus X bar and Y minus Y bar, that values are coming like this. So X minus X bar, it's so whatever the values we have got here, X minus X bar, if we take square of that, then square of minus 2 is equal to 4, minus 1 is 1, 0, 0, 1, and like this, the square terms we have got here. Similarly, X minus X bar and Y minus Y bar, this particular multiplication, if we take here minus 2 into minus 2 is 4, 1 into 0 is equal to 0. Likewise, these values we have got here. Then substituting in this equation which we have solved recently by considering the least square approximation technique, with that will come that beta 1 is equal to summation of I is equal to n 1 to n yi minus y bar upon into xi minus x bar divided by summation of I is equal to 1 to n xi minus x bar. So substituting these values, so this particular multiplication bracketed x minus x bar and y minus y bar, this is coming equal to 6, and then substituting this summation of x minus x bar, it's a square here, which is coming equal to 10. So beta 1, which is equal to 0.6 here. Is it okay? Likewise, for beta 0, now y bar minus beta 1 hat x bar. So by substituting this y bar as a 4 and this beta 1 x bar, here we will be x bar is considered to be 3 here. So beta 1 hat x bar, based on that, so beta 1 is calculated as 0.6 by substituting here 0.6 into 3, and then 4 minus 3 into 0.6. So likewise 4 minus 1.8, which is equal to 2.2. So beta 0 that will be considered to be 2.2 and beta 1 is considered to be 0.6. With that, this particular model has been developed, and which comes as y hat is equal to 2.2 plus 0.6x. So here we can understand these things. Is it okay? So with this example 1 is completed here. So beta 0 we have beta 0 hat we have referred as y bar minus beta 1 hat x bar, and beta 1 hat is referred as summation of yi minus y bar xi minus x bar summation of xi minus x bar, it's a square. Is it okay? So here with simple equation which we always use, y is equal to beta 0 plus beta 1 x plus epsilon, with given xi yi, I is equal to changing from 1 to n with least square method that determines the parameter by minimizing this term. So we got this. So least square method determines the parameter by minimizing these particular terms, and with this now, with this example, so parametric estimation solution. So here, same example with these terms or with these particular notations, we can once again calculate. Here you can take one more. Same example is solved here. So we can see here that xi, yi, the summation of xi 15, summation of yi 10, xi square 55, yi square 26, and xi yi 37. Example is same example, but here we have calculated based on this beta 1 is equal to summation I is equal to 1 to n yi minus y, which is converted. So beta 1 value which can be considered to be with small modifications, because we have considered a beta naught hat as equal to y bar minus beta 1 hat x bar, and beta 1 hat, that is in previous example we calculated here with reference to this summation I is equal to 1 to n yi minus y bar or x minus x bar. So same thing with simple manner can be calculated by small modification of this equation. So beta 1 hat, which is given to be summation of xi minus x bar yi minus y bar, after multiplication of this xi and yi, this particular numerator terms are multiplied with each other. Similarly in denominator also, that are separated from each other, and simple manner this sxy sx, that is this ratio is given to be summation of xi yi minus x bar y bar n. So summation of xi square minus nx bar square. Is it okay? So with this this particular model, that is advertising same equation, once again same example we are continuing here. So with this xi 1 2 3 4 5, like this variables are there, and whatever the values we are getting, that is again yi 1 1 2 2 4, that are we are getting. So xi square is calculated, yi square is calculated, and xi yi with this these notations which are used here for calculating this beta 1 hat and beta naught hat. So for this summation I is equal to 1 to n xi yi minus n xy bar. So this xi yi is 37, which is used here, it has 37. Then xy, for that n number of variables used here, 1 2 3 4 5 number of variables are there. So with this n we have used the term of as a 5. Then x and y, that mean is there. So x mean is this 15 divided by 5 is equal to 3, and this 10. So 10 divided by 5 is equal to 2. So this 3 into 2. So n is 5, x bar is 3, and y bar is 2. Similarly, this xi square. So for this xi square, this value is 55, and this n x square, this x square value is considered to be x bar square, that is considered to be 3 square. So substituting that, we got, so beta 1 hat is equal to 0.7, and here beta naught hat, by substituting these values, we got y bar, y hat is equal to 0.1 plus 0.7x. So this is the fitted equation for this any particular value. So coefficient of interpretation, so slope beta 1 hat, sales volume y is expected to be increased. So what is interpretation based on that? The interpretation tells us that, so beta 1 here will beta 1 hat will be considered to be coefficient of interpretation. So here sales volume y is expected to be increased by 0.7 with each dollar. Is it okay? Then coefficient of interpretation, y intercept, that is beta 0 beta naught hat. So that is the y intercept. So 0.1 units when advertising x is 0. This is somewhat interpretation given here. Is it okay? Now coming to some another points of this regression part, that is what is meant by multiple r, then what is meant by r square value, then what is sum of square, then how to identify the f values and p values, or the f test, t tests, etc. We will go further that suppose this is one more example we have taken here for our reference. This particular first y, and this x means square feet. If we want to purchase the particular house with 1,400 square feet, 1,600 square feet, 1,700 square feet, like this particular second row represents the values in square feet, and this first row represents the cost of that particular house in rupees. Means as square feet is increased, then cost increases. Maybe this is in simple manner happens, but still if we are going to plot, we are going to make the plot of all of these. So here the values of x and values of y, as usual, first of all initially plotted with the help of scatter plot. Already we are familiar with this scatter plot. So with this intercept and slope, suppose this equation has been plotted. Means suppose we are using this beta naught beta hat, that also, or by using with the help of this analytical method, that is the best method which is used to calculate beta 0 and beta 1 hat, because this is coming from this minimization of this this particular least square approximation. So with this, suppose this equation is plotted here, and we got that house price for that this beta 0 value is 98.24, beta 1 value is 0.10977, and into its square feet. Then beta 0 is the estimated average value of y when value of x is 0. If x is 0, the range of observed value, so here we may have some values we may predict with the help of this particular example. Suppose so house price, the whatever the model we developed here, that model gives us house price is equal to 98.25 plus 0.1098 into square feet. Then predict the price for the house with the 2,000 square feet. Means here we will have to substitute here it as a 2,000 in order to get the price of the house. So that is substituted here with this example is solved. Suppose square feet is 2,000, which is put here, and the house price is calculated to 317.85 into this $1,000, which is considered as a unit of that. So by that way we can calculate them. But our intention is to understand the various terms which are associated with the regression analysis and which make impact from many times the research point of view here, because multiple R. So this is the correlation coefficient, and it tells us how strong this linear relation exists. Means suppose we have established any model, we have developed any equation, but whatever the expression we have got with this value of y and x, how correctly it will work? What is the prediction with the help of this particular model, or with decided assumptions and with the decided things, how this particular model will work? So that parameters will be controlled, that will be verified with the help of some of the parameters, and for that multiple R and R squared values that will help us. So now what is that multiple R and R squared values? So for that purpose, multiple R is the correlation coefficient, and it tells us how strong a linear relationship is. For example, a value 1 means a perfect positive relationship, and a value of 0 means no relationship at all. Means as value of R starts to increase from 0 to 1, that indicates that as this is a reach or close to the R value, the accuracy is model is right. And if suppose that value is coming close to the 0, then particular model is not so much accurate. So based on that, so multiple R is always square root of R squared value. So R squared value are calculated, and it is the statistical measure that represents the proportion of the variance or dependent variable. So that is explained by independent variable or variables in the regression model. So how that are calculated? So simple way to calculate the R squared value is R square is equal to 1 minus SS residual, so sum of square of the residual upon sum of square of the total. So for that purpose, now we will take one example to identify the sum of square of the residual and sum of square of the total. So sum of square of the residual is always calculated from summation I is equal to 1 to n yi minus y hat, it's a square, and sum of square of the total is calculated based on the summation I is equal to 1 to n yi minus y bar, it's a square. Okay. So we can understand here yi, that is the actual value, y hat is the value calculated from the model, and y bar is the mean value of that y. Is it okay? So with this, r square is the sum of squares explained by regression and total sum of the squares, which is considered to be coefficient of determination. So here, coefficient of the r square value will be considered to be coefficient of determination. So see here, in the single independent variables, in case of coefficient of determination, so r square value, so how this particular value is calculated and how it will determine the particular model, what we can say the accuracy of the model. So example of approximate r square value. So for that purpose, suppose this particular graph is plotted here, x and y, and r square, all the values are coming on this particular line. So this is very ideal case, which is not possible in actual practice, but in order to come to know that what is actually r square means, so for that point of view, this example is taken. Suppose all the values of x and y, these are coming on a single line, that indicates that r square is equal to 1. And in this case, we will consider that there is a perfect linear relationship between x and y. But that is 100% of the variation in y and explained by variation of x. So r square is equal to, maybe it is positive or maybe it is negative side of relationship between x and y. But that can be given with r square is equal to 1 if all the values are coming on that particular line, and then we will consider that exact relationship exists between them. Now here if we take the second case, means suppose for this x and y relationship, many number of random results we are coming in between x and y. All these are random in positive side. If we take example, if we take the negative side of the example, and if it is not coming exactly near to 1, it is shifting towards the 0, then this particular r square, suppose third case is also taken here, suppose r square is equal to 0, then no linear relationship between x and y. In that case, this particular model we will have to model with the, we will have to fit with the help of some another technique. Means initially we have considered that in between y and x, though they are dependent with each other, so linear relation we have plotted, but we need to go for the non-linear relation between x and y. So maybe it is cubic type of relation or any other type, quadratic type of relations, but that type of relations we now will have to with this particular y and x are related with each other with that way, by non-linear way. So this linear possible. So this will be decided, whatever the model is developed, after development of that model, the value of this or the performance of, we may consider as performance of that developed model. So here for that purpose, actual values and these calculated values from the model that are calculated, and with that, suppose this is one example that r square is equal to 0.6. In second case, that r square is equal to 0.9. Then r square is equal to 0.9 has good performance, wherever r square is equal to 0.6 is weak in the performance. So that is that we can predict with the help of these two examples. Is it okay? So calculating r square using regression analysis, r square is the statistical measure of how close the data are to be fitted on the regression line for measuring the goodness of the fit, or it is also known as coefficient of determination. Firstly, we calculate the distance between actual value and mean value, and also calculate the distance between estimated value and mean value, and then we are comparing both the distances. Is it okay? So with that way, this is calculated. So small one example we will take here in order to identify this R square value, in order to identify that whether that particular model which we have constructed is more suitable or not. With same example we will continue. Suppose X is as usual the advertising cost, and Y is the we can say at a sale. So 1, 2, 3, 4, 5. Likewise, Y is 2, 4, 5, 4, 5, and then Y minus Y bar values which are represented with this third column. Y minus Y bar, it's a square that is given with this fourth column, and then what is meant by Y bar, hat. So already now we are familiar with this concept, how to calculate these terms. So y hat minus y bar, y hat minus y bar, it's a square. And then this already we have gone through this particular relationship, that how to identify this R square value. With this way we will try to identify the value of R square. So summation of this y hat minus y bar, it's a square, divided by summation of y minus y bar, it's a square, that gives 0.6. So 3.6 is here and 6 is here, which will give the value of R square. So with 0.6 closeness, this particular model is accurate. Is it okay? Here we can see that it is if these values come towards the 1, then we will say that this is actual close model. So whatever the values we will get, that will get near about 100% correct. But as 0.6 is the value, which is the we can consider as the value of R square, or here for this R values we are considering this kind of coefficient. Is it okay? Which will decide the goodness of the fit. Okay. Then adjusted coefficient. So adjusted R. There is one more concept, that is adjusted R. So adjusted R square are always takes on the value between 0 to, this is also like that of R square value. The closer adjustment R square is to 1, the better the estimated regression equation fits to the explained. So same prediction, whatever the prediction for R square, same is for adjusted R square also. The value close to 1 are considered to be the model is good fit model. Is it okay? So like this, here we can say the key difference between R square and adjusted R square. That is R square increase. Why adjusted R square is required? Though R square is present there, why adjusted R square is required? So the key difference between R square and adjusted R square is that R square increases automatically as you add new independent variables to regression equation. Suppose 5 readings are there and you have identified the R square value. If suppose 10 readings are there and you have identified the R square value, in both the cases adjusted R square value will be different, because the key difference between R square and adjusted R square is that R square increases automatically as you add new independent variables to a regression equation, even if they don't contribute any new explanatory power to the equation. Okay. So therefore, you want to use adjusted R square with multiple regression. Is it okay? So for that purpose, here if we take one example, then we'll come to know that. So multiple R value, that is suppose here coming 0.9717 like this. For R square it is coming 0.9443 like this. Adjusted R square value is calculated based on this R square value. So here we can have the formula to calculate the adjusted R square is that, so R square bar, that is adjusted R square value, is equal to 1 minus, in bracket, 1 minus R square in another bracket, n minus 1 upon n minus k plus 1. Here R value is the multiple R value which is calculated as shown in previous example. Then n, here we may consider that number of the x values we have considered here. So that simply we will consider as n, or number of variables we may consider here it as. So k is considered as number of independent variables in the model. Okay. So n is variable, k is number of independent variables of the model. So here with this adjusted R square value is calculated, and that adjusted R square value that is lesser than R square value. Is it okay? So whenever the regression analysis tool is by simple manner, we can calculate with the help of Excel also. This facility is available with Excel. But after getting the results in the Excel, how to read them, how to identify the meaning of each and every term. So that is shown here. So first multiple R, that now we have identified with one example. What is meant by R square? So R square, the ratio of R, the root of R square is multiple R. How to identify R square? That we have seen with one example. How to identify R square value? That we have seen here. Then standard errors, how many number of observations are there? So that part we have seen, and with the help of this intercept, suppose coefficients which are shown here, so with a simple Excel sheet, if we are plotting this particular example, and then we are getting its answer as 98.24833, then that will be considered as coefficient of intercept, and that is nothing but beta 0 hat. And this square, this is 0.10977, that coefficient will be considered as beta 1 hat, and then this particular model can be considered as a house price is equal to like this. Is it okay? So this about the various terms associated with the regressions. So standard error estimation. So in this there is one term, that is standard error. So how to calculate the standard deviation of the variation of observations around regression line? So that is estimated with this sum of square error. So here we are taking under root sum of square errors divided by sample size minus number of independent variables in the model. So like this we can have this particular standard error of regression slope coefficient, and it is estimated by suppose estimation of standard errors of the least square slope. With this one formula, this estimated value of sigma in simple manner, this is estimated as under root of summation of y minus y at square upon n. So we may see here with this small example that standard error estimation, how it is calculated, the value of x, then value of y. Then here we can have these terms associated with this y, and y minus y hat, y minus y at square. So by substituting simply these values, we will get this standard error estimation. Is it okay? And coming to the last part of this one, that is analysis of variance, because R square, adjusted R square, the standard errors, that are the ways by which we can decide that how this model is close, how this model is good fit. So like this, there is one more test that is considered to be ANOVA, that is analysis of variance. So here for that purpose, suppose y is equal to beta 0 plus beta 1 x epsilon, y hat is equal to beta 0 hat plus beta 1 hat x. Then with these assumptions and hypothesis that beta 1 is equal to 0 or beta 1 is equal to beta 1 is not equal to 0, the value of any parameter t, so test parameter t, that is calculated based on beta 1 hat divided by under root of this mean square of residual upon this s sum of square of xx. So with this there are certain assumptions that this t, if it is greater than t suffix alpha by 2. So with this the total variation in the data, suppose variation where ANOVA means analysis of variance. What is the variance? Actual value which is coming from the experimentation and predicted value. So in between that, whatever the difference is there, so that is considered to be variations. And here we are analyzing that variance. So that's why analysis of variance. So ANOVA, that is the long form for this analysis. So total variation in the data is summation I is equal to 1 to n, yi minus y bar, its square. So as already considered here, yi is the ith value. I is equal to 1 to n. Y bar is the mean value. So that particular difference. Here for the sake of simplicity, this yi minus y hat, this particular equation is rearranged. So yi minus y bar, that is rearranged with this equation yi minus y hat is equal to yi minus y bar minus y hat minus y bar. So deviation of ith observation from its predicted and deviation of the true. So this particular equation yi minus y, this is only just adjusted. That means it is we may in simple manner we may consider here that y bar is added and y bar is subtracted. Is it okay? Y bar subtracted term is given here. So minus of minus y bar, this plus y bar and this minus y bar will get cancelled here, and this will be yi minus y hat. So yi minus y hat is converted in this form in which y bar is term is present and y hat and y bar term is present. Now this particular case we will try to study with this particular graph, that yi minus y bar is equal to yi hat minus y bar plus yi minus y hat. So let us have this particular xi value which is shown on this horizontal x-axis. Xi means any ith value of x is shown here, and corresponding yi value is shown on this line. Is it okay? So this line is nothing but the model or the fit. This particular with the help of regression equation, this model has been plotted, and this corresponding value of yi is considered to be yi hat. So yi hat is the value which is coming from this calculation. Is it okay? Now, if suppose yi is actual value, means yi hat is calculated based on the calculations, but yi is actual value which is coming after experimentation or actual results is yi, then there is a difference between yi and yi hat. So that difference is given as yi minus yi hat. Is it okay? So yi hat value is here, yi value is here, but mean value of y, that is given as y bar, then y bar is the value which is shown here. Is it okay? So the difference between this yi hat and y bar, that is shown here. So yi hat minus y bar, so that difference is given here. Then the third difference, that yi and y bar, so that three differences now we can understand here. Yi minus y hat, that means the difference between actual value and modeled value. Yi minus y bar, that is the difference between y and mean value. This third one is actual modeled value, difference between modeled value and mean. So like this. So here if we take the summation of here, then summation I is equal to 1 to n yi minus y bar its square. From both sides this summation is taken here, and with that summation here it has been considered to be cross product on t, on tutorial t terms. So with this mathematical part in depth we will go with this slide. We can see here that y hat minus y bar is equal to beta 1 hat xi minus x bar, that already relation has been proved here. And yi minus y hat is equal to yi minus, by substituting this value we got yi is equal to y bar beta 1 hat xi minus x. So with this beta 1 hat can be considered as sxy upon sxx. Is it okay? So like this with this particular equation or this model we may consider as total sum of square is equal to sum of square of regression plus sum of square of residual. Is it okay? So SST, that represents that sum of square, total sum of square of total is equal to sum of square of regression plus sum of square of residual. So sum of square of regression is equal to summation from y hat minus y bar its square. So by substituting these values here, sum of regression beta 1 hat its square into sxx. Is it okay? Similarly, sum of square of residual, so that value is summation I is equal to 1 to n yi minus y hat its square. With this and this the variation which is not explained by a regression variable, and if this is the degree of freedom with also degree of freedom at the addict properties. So here degrees of freedom total is equal to degrees of freedom of regression plus degrees of freedom of residual. So sum of square of this total that values with that has a degrees of freedom n minus 1. This total concept of this particular in terms of degrees of freedom, if it is written, then we will come to know that sum of square of the total is equal to sum of square of regression plus sum of square of residual. Is it okay? So by that way, this ANOVA table is plotted here. So source of variation is regression, residual. So degrees of freedom are 1 and n minus 2. Then sum of square of regression and sum of square of residual. So these terms are here. So mean of sum of square. So that values are plotted here, and based on that, the f value is plotted. So f will decide the particular, we may consider the test. So this f test or test is considered to be one of the parameter with which this model can be tested. So how this regression model is tested? With the help of this f test. Is it okay? So the f is equal to mean square of regression divided by mean square of residual. So total here it is this expectation of mean square of regression. So that is sigma square minus plus beta 1 hat SX. So here with statistical theorem, it is said that let x follows chi square m and y follows chi square n, then they are independent. Then x by m and y by n, this follows f with the degrees of freedom m and n. These quantities divided by this. So defining now with 1f for ANOVA table and this calculation of f with this approximation. So we will come to one example here. So with same example we will continue here. That suppose advertising cost is 1, 2, 3, 4, 5, and this particular outcome of this in terms of sale is coming 1, 1, 2, 2, 4. Then with that this particular model is formed. So yi hat is equal to 0.1 plus 0.7 xi. So sum of residual, for that purpose here the reference is taken that source of variable is regression or residual. Is it? So for regression there is degrees of freedom 1, residual there is degrees of freedom 3. So sum of square of residual and sum of square total is equal to summation yi minus y bar, it's a square. If we calculate them, then sum of total sum is coming equal to 6. Here we can see sum of this total sum, square of sum of the total, that is summation of yi minus y bar, it's a square, which is coming equal to 6. And if it is identified for regression and residual terms, then sum of square for regression is coming equal to 4.9 and sum of square for residual is coming equal to 1.1. Is it okay? So based on that, the value of mean residual is calculated. So for mean residual calculation here we can see that the sum of square regression we have got as 4.9 here. So sum of square we have got as 1.1 here. So 4.9 divided by 1, that is mean of sum of square. Is it okay? So MES is mean of sum of square, that is 4.9 divided by 1, it is 4.9. And for this residual, that is 1.1 divided by 3, this is coming equal to 0.367. Is it okay? So 4.9 divided by 0.367 is coming equal to 13.6. Here value of f is considered to be 13.6 here. Is it okay? So with that hypothesis and with this particular way, the calculation of f will be decided. So f is to 13.6 and f is considered to be t square. Is it okay? So t square is calculated with this particular assumptions and hypothesis we have already considered while plotting this one. So here t is equal to beta 1 hat divided by under root mean square of residual divided by SXX. So here with this, by substituting the values of this beta 1 and this mean square and this SXX here, the t value is coming equal to 3.655. Is it okay? So f is considered to be 13.61 and t square is considered to be equal to, is calculated equal to 3.655. Is it okay? So with this, the value of f is calculated, and this particular tests of t test, f test, that is carried, and based on the values of this r square, f value, t test, it is decided. So coming to this particular output, so any output, so if we use the software like Minitab, if we use the regression analysis, then also we will get this kind of results. So after getting that results, we will get the multiple r value, r square value, adjusted r square value, standard errors, how many number of observations you are going to use, then sum of square, then mean of sum square, then f test and significance of f. So that all these things are calculated. So these are the way by which these are calculated. These are calculation ways. So I must thank to the this NPTEL project, Professor Sumen Maiti and Department of Mathematics, IIT Indian Institute of Technology, Kharagpur, for this particular way they have given the information of the regression here, and these are some of the references, applied regression analysis, as well as introduction to linear regression analysis. So thank you all, thank you very much.
Participants, anyone have any type of question? Please ask.
Hello, good afternoon, sir.
Good afternoon.
I received one question from participant Vijaya Firke. Question is, what is the use of regression analysis in daily life?
In daily life, there are many more things with which we can establish the relationship. If suppose we take a simple example, suppose in economics, if we take economics, or in share market, if we see the industrial growth, then it may be in terms of management also, or in simple experimentation also. So all these things, wherever the terms are dependent with each other. In simple manner, if we take the example of season also, for last 4 years, if we take the example of summer season, what was the temperature raise for the summer season from last 4 years, and what will be the in next year. So for 1, 2, 3, 4 like this, if we take the temperatures, and if we want to plot the particular graph with this, and if we be able to identify the proper parameters with certain proper assumptions, or with some dependent variables, independent variables, then we may predict that what will be the situation coming for the next years also, etc. So these are some of the simple examples. So already we have seen that these have applications in many fields. Maybe it is management field, or economics, or engineering, sciences, and many more. Wherever there is a relationship between dependent and independent parameters, that kind of relations can be established. So that may be multiple parameters, or that may be single parameter, like this.
Okay, sir. Thank you.
Thank you very much.
Sir, good afternoon, sir.
Yes,
Hello.
okay.
Sir, I have a small doubt, sir. So my name is Jabin, sir, actually. So in this analysis of variance you have taught at last. So can you please explain what is the purpose of going for analysis of variance? And along with that, I also have few other doubts, like where this F-test, T-test, and chi-square test are used. Because these kind of things are all confusing. I have learned so many books, but I cannot get the clarity about all these things. Why this analysis of variance is used? What is the purpose of using that? Can you please explain?
See, sir, here I will take the output which is coming from the softwares which already discussed with the regression analysis or with the help of any software like Minitab also we can identify the relationship between them, and we will get definitely directly output. So I coming to this output, I will come here and I will tell you that suppose this value of f we are calculating with this with the ANOVA table which is shown here. So already we are now with this familiar with this degrees of freedom, then sum of squares, then mean of some squares. One example we have studied recently now. So how these terms are calculated, and based on that terms this f value is calculated. So each and every value there is always there is significant. So f is maybe this tests which are considered with the help of this f tests we are considering. So if suppose we have considered that f, suppose wherever that model is valid or not valid, so validity of model that will be based on these particular factors. Means suppose now here f we have calculated as 13.6, and if suppose for any conditions for f is equal to 0.051 1:3 it is coming for this with the hypothesis S0 and H1 it is coming 10.13. So if this whatever the assumptions we have considered that is valid, then we can consider that this particular model is accurate type of model and this will work. So like R, this is one kind of another test. R test is one kind of test. Likewise, this F test, ANOVA test is one kind of we may consider as F test. So that will give the validity or accuracy of the model.
Okay, sir. So what about the t-test and the chi-square test? T-test.
So t-test for that purpose we may consider as a t square in any parameter. Here we have considered as a t square is equal to f, and with that we have calculated this.
Okay, sir. Thank you. Thank you.
Thank you.
Sir, one more question. Dr. Rakesh Mishra sir asking question. What's the important correlation regression for prediction on big data?
So for big data, how many number of parameters are present there? Based on that, once you establish the relationship between them, then whatever the model you get, the accuracy of that models will be verified with the parameters which are the decided parameters. So if we are getting the satisfactory results with the help of these controlling parameters or deciding parameters with which the accuracy of the model is decided, then we may consider that this particular process of modeling with the help of this regression is accurate or not. Or we may have correction values. If suppose we are not satisfied with these particular terms which are coming or which are testing, so model testing of that model, if it is good, then we can continue with that particular model. But with the help of the tests, if we are not getting the satisfactory results with reference to these parameters, then we may have to try this particular model with some another way. Is it okay? So there are many other ways by which we can by non-linear way, by or non-linear way, cubic, quadrilateral, or some another ways we can try this particular model. So with these models, if we are satisfied with the results which are coming to us, then we may consider that this particular model we can use for this data also.
Thank you, sir.
Thank you. Thank you.
Okay. On the behalf of Sinhagarh College, I am very much thankful to Dr. Sonand sir for his very wonderful, very nicely organized presentation on regression analysis. And session was very wonderful. So many comments are received in the chat box regarding the session. That was well organized, flawless, no interruption, nothing. So thank you very much, sir, for your nice presentation. So with this, I'm concluding today's first session. Our next session will be begin at. With this, I'm concluding first session. Thank you, one and all.
Thank you very much. Thank you.